Hello everyone. The data structure list is usually implemented using array or linked list. We used to say array implementation is a contiguous way of implementation. Why we say array is contiguous? Let us see by an example in C language. When you declare an array of say size 5 with some data like this, I have 5 element array. It is having these data, integer data. If you declare this array, this 5 elements, each of which having 4 bytes, totally 20 bytes will be allocated for this one. This 20 bytes will be contiguously allocated. The meaning, it does not have any gap between them like linked list that used to have. So if you want to verify how that is happening, so if you usually print the name of the array, it actually points to the starting address of the array, or you can say first element's address. So that you can just see by this printing. If I print the name of the array A, you see what it is printing. So it is printing 6487552. So ending with 552. Okay, so that's the start of the array. So the array name actually is nothing but an address of the first element, or you can say address of the block that is allocated. Okay, so if I want to verify how this matching with first element address, we can explicitly mention address of operator for the first element, which is the 0th element. So that also I can display. So if we see this array name, address and the first element address, both are same. Okay, so if we print all the elements address, we will see how the address range goes. So for I'm printing this ampersand of F5. So it is not giving any gap. So let us see with exclamation. So this address of elements. So I can print the data also. So we'll print both together. So first it prints the data, then its address. The 5 is the data and its address is 552. Then 323. 556, 560, 64, 68. 4 bytes, 56 minus 52, 4 bytes, 60 minus 56, 4 bytes. So if you see the 4 bytes allocated for 5, 4 bytes for 323, 13, 4 bytes, 62, 4 bytes, 23, 4 bytes, and all are contiguous. If we see the address range, 552 plus 4, 556. Then again starting from 556, 4 bytes. Then again starting from 560, 4 bytes. So this is a contiguous allocation. So why we say this contiguous is needed for the direct access? Because array is famous for direct access. You can access any element directly. If there are 1 million elements, I can access the 10,000th element directly. Okay, so how to do that? It's actually happening like that only. Now let me print and show you. So now we have this array. If I want to print this 4th element, okay, how to do? Say we usually put A, which is a start address. A means starting address. Okay, A is the start address. Now A plus 4th element I need to do. So this is A actually. This is A plus 1, A plus 2, A plus 3. So A plus 3 will do. Okay, then it's a value add. So it's a address arithmetic. So if A's address is, for example, A's address is 1000. Let us assume A is the 1000. It's the address of the starting place. Plus 3 if you do, this is not normal arithmetic, it's a address arithmetic because you are adding 3 with an address value. So 3 addition will be making the address pointer move. So here we are going to point to some other place, some other location, that means some other address. So plus 3 means how much to move, it just finds out. So because the data type is integer, 3 integers we have to shift. So that means for every integer 4 bytes, 3 into 12, 3 into 4, 12 bytes. That means we have to shift 12 bytes. So the answer will be 1000 plus 12 equal to 1012. So this will be the address actually. So A is 1000 plus 3 will make it to 12. Okay, then 1012. But if it is character, if this is character, then 3 into 1 bytes, because for each character it is 1 byte. At that time it is 1000 plus 3, 1003. But we have given integer. Okay, but if we give float that's also 4 bytes. So first we will verify that. So if I do a plus 3, what it is printing, let us see that. Ending with 564. Okay, that's what a plus 3 is. This is the address. Okay, so if you want to see what a also, you just put percentage d. A also, let me see. So a is 552. Then if you add 4 bytes, it is 56. Okay, that is a plus 1. A plus 2 is 52 plus 2 into 4, 8. That means 60, 560. A plus 3 is 3 into 4, 12. 12 plus 52, 64. That is what happened here. Okay. Now this is the one which is pointing to certain location in the chunk. So if I put star of this one, that means that's a valued operator. What it is pointing to? It's pointing to third element. Zeroth, this is zeroth element. A plus 0, this is a plus 1, a plus 2, a plus 3. So it will be printing 62. Okay, so this is the advantage. So this is where we are doing a direct access. The direct access is possible only because of this kind of continuous allocation. If the contiguous allocation is not there, that means we cannot work out this logic, because we just work with only the base address plus 3. If there is a gap between the addressings or memory allocated, we cannot just do this base addressing plus offset. This is actually offsetting mechanism. So A's base address is 1000, and if you are adding 4 to that, what is the size of data present? Okay, that you have to do. So if you are adding, say I am adding 8, that means size of data is 4. Okay, size of data is 4, that means 8 into size of data. Okay, so that much it will move. That's arithmetic actually. So if I add 8 here, if I add 8, it's actually 8 into size of data plus 1000. That's what will happen here. Okay, so the size of data is determined by type of the array you are declaring. So as I mentioned to you, if I declare integer array, it's working in this way. If I declare double array, if I say I'm just declaring double, this is a double array. If I do a and or you can say a plus 1, you will see the difference. A is 536 and this is 544. How many bytes? 8 bytes. 8 bytes are allocated for one data because it is double. So this one only defines how much this address arithmetic will be giving out once I do arithmetic in the address. So this is an address arithmetic. This is not a normal arithmetic because A is an address. So this direct access is made possible only because of contiguous allocation. If there is gap, we cannot do. Okay, so that is why we say search is very fast in arrays. Thank you.